Hey everybody, this is Brad Dyke doing my logical video, which is not necessarily on the hardware, but more on the logical processes of troubleshooting. Today we're looking at two DX720 arrays, both with 10 gig pipes, but one is not acting quite right. So what I'm going to do here, this is just a short little video about diagnosing these situations. Here you see on my Mint Linux environment a 1 gig connection sustaining a 102 to 110 megabit connection and has been doing that for quite a while, transferring 100 gigs of data over to a TrueNAS Dell R Series 720 DX. That's a 24 disk array platform with a 10 gigabit pipe, which it is set up for. Now, the good news is this new TrueNAS platform, which I've set up, in comparison to its exact brethren, the first one, shows that the usage on this is sustained, it is stable, and it's consistent. Now, the way I did this was pretty simple. Basically, in a nutshell, what I did was I have two Dell R720s. One wasn't acting quite right, and I could watch the bandwidth just taper off until it almost crawls. But the chassis has plenty of resources, plenty of firepower, plenty of capability, and it shouldn't be tapering off. I did a couple of basic things. One, I built a second DX720, put it side by side, same switch, same 10 gigabit NIC, paired up with the first one, and I said, okay, so I have a Linux Mint environment, 1 gig to 10 gig. Do a transfer rate, I should see something like 80 to 110 megabit transfer rates sustained. And I said, okay, let's dump the first 100 gig over the fence to the older system, which is a TrueNAS platform. And it started out decent, and it started to dwindle and just started to come down. I noticed this was an oddity with the platform, so I said, okay, not a problem. Let's do the exact same steps. I copy the 100 gigs off my local PC. I paste it into the new TrueNAS DX720 with its 10 gig pipe on the exact same switch. And the result was 105 to 110 megabit sustained transfer rates. As it stands right now, the transfer rate is consistent for the past 12 minutes, and we'll finish up very quickly. Now, I did the same test on three 10 gig connections, but because of the fact that it's a 10 gig connection, there is a little bit more play in the bandwidth. I needed to see the up and down effect, where it was kind of going up and it was fast and then it was down, then back up and then down, back up and down, over and over and over. Or worse yet, watching the NIC onboard caching process just completely max out and just crash. And that's exactly what happened. That's not good. Now, the key caveat to this process is that the new 720DX platform has 100 gig SSD burst cache in the front end of a series of 1 terabyte SAS disk. Now, the other platform, the other DX, the older one, doesn't have any SAS disks at all and is running off of a disk array. And that is below on the environment. So with that being the case, I thought, okay, so I think I have an idea of what's happening here. I noticed that when I rebuilt the second 720DX, that was the one I did the video on with the new motherboard and all of that, I put in a Dell standard industry motherboard, not an OEM whiteboard, which was used by Google. By doing that, I had caught the oddities of the NIC that was with it, the 10 gig NIC, and I said, okay, well, let's pull that NIC out and let's get a new one, which I did. I bought it and I brought it in, and bam, that sucker went all the way across the top, no issues whatsoever, performed very well the way I expected it to, and it gave me the end results that I wanted. So with that being the case, I've decided that I am dealing with probably both a NIC cache issue and a RAM buffering issue with ZFS. And RAM buffering does apparently seem to be something that sticks with TrueNAS a little bit on the ZFS side of things. I see it on occasion, but when the NIC starts going up and down and pulsating, it just exacerbates it a lot more. And that's not on TrueNAS, it really isn't, and not on ZFS. It's on the hardware stability to the protocols that are trying to run on it. So with that being said, I'll give you a quick blurb here in just a second of what it looks like on the older DX720 versus what we have here now on the current, the newer DX720 platform here, as you can see. So give me just a few minutes here and I will set that up so that you can see how the alternate pathway dwindles to almost nothing. It's a very interesting example for network traffic code sampling. Okay, so that copy is finished and it did it in a pretty decent format and was fast. So what I'm going to do now is I'm going to go ahead and paste my video sample of 100 gigs of capacity, and as you can see down there, it is set and calculating and beginning the process. So here we are starting to watch the workload pick up. It did not reach 100 better megabit. It reached about 199, starting to crest into the 102 range, but is now starting to decline more. And as you can see here on that process, it's stepping down. Look at that. Now, that pitch and variance is not correct, but it gets worse. So as we sit here and monitor this for a few minutes, you'll see that decline effect begin to kick in about roughly every about one gigabyte of data. And that's telling me that the cache effect is starting to wean off. So when I start building it up into capacity more, and the transfer rates are starting to hit harder, look at the degrade on it. Now we're at 58 megabit, and it's only been literally about a minute or so. And when this begins to happen, you also start to see that right there? It is bottoming out now at 25.27 megabyte. And megabit, and that's not good. That's not healthy at all. This is what I was talking about, cache cycling. When you have nothing to set for caching and your write cycles at the NIC aren't refreshing correctly, it just dwindles to almost nothing. And then you start to get alerts saying, hey, I failed to copy, I failed to transfer. Now, what does this basically mean for me? Well, in a nutshell, not good, because I have a lot of data on this platform. So the question is, how can I get the majority of this data off without these pits and valleys that I'm seeing here? And it's going to require that I do what's called a stage transition. Normally I have duality on my data. In other words, I have two actual sources, usually my active, and then I have my recursive archiving. But right now I'm only down to one chassis, so I only have archiving out there, and I'm going to have to hybrid the data transfers using a third client and bring them over in probably asynchronous style staggering process. In other words, set by folder by folder by folder. ISO images, MP4s, and so on will be the hardest to transfer, and as you can see, the NIC is trying to do what it can do, but it just doesn't have the resource to do what it has to do. And as you remember, when we were doing this, the transfer rates between the two servers just don't match at all. As a matter of fact, let me give you an example. What I'll do now is I'm going to cancel this job because it's going to crash anyways. Go back over here, go into the alternate platform. Let me rename this guy. I'll just call him old. And then I'm going to, this is the newer DX720, and I'm going to paste, and we're going to see how it's going to cycle up. Now notice again on the cycle process how this picks up and is staying at roughly about 108 consistently with a little bit of pitch, but it's not much at all. Never does it degrade. And this is how you can do what's called endpoint network testing by doing comparative components. In other words, everything is sitting on the same set of resources. I am coming from a high-end 1 gig switch for the house bandwidth from my desktop all the way to my lab environment, which hits the 10 gigabit, which means I'm going to get full allocation. And as you can see here, I'm getting full allocation. And it's going to sustain the allocation constantly until the data transfer is done. Now that should be consistent with both DX720s. So I'm going to have to decommission my old 720 once I've got all the data transitioned over. That's going to be a challenge because it's going to be up and down constantly until I get it all completely off. But I'll get it done. And then I'll have to pull that 720 apart and figure out what's going on with it. Am I dealing with something more principalized? Am I dealing with cache dumping? Am I dealing with a NIC failure? I'll find that out. But I thought you guys would enjoy this particular type of testing. It's a logical test. It's not a physical test process. It's more of how you build a control sample versus a suspect sample and compare the two together. And like you saw, we've already gone into 2 minutes here, and it's just not budging. Its average is about 200. Is about 106 megabit, and that's what I like to see across all my 1 gigs because I have a high-end backbone 10 gig architecture, so that allows me to have a lot of inbounds and outbounds simultaneously, about 7 or 8, and getting this kind of bandwidth, and that's what I want in general. Well, this is Brad Dyke, and this is just my logical video that I post that I figured you guys would get a kick out of. And never be afraid to think outside the box. This test I did was something I kind of invented indirectly because I wanted to use the Mint Linux tools with the KDS Plasma add-ons to just kind of fill in the blanks with my own GUI type like testing. Yeah, I could have done this with CLI. That's kind of boring and I can't do comparisons and so on. So with this I can. And it's not so serial, it's more like side by side with other resources available. And it's a pretty good capacity in regards to working with making sure your hardware server is going to perform the way you want. So with that being said, this is me signing off. God bless. Hope you guys have a great week. You take care. Bye-bye.